X and Y.
You switch the variables. That's step one. When I say switch the variables, it's just straightforward. Wherever X is, put a Y. Wherever Y is, put an X. What's step two?
And solve for Y.
That's it.
All right.
There's the inverse of this function. And whatever you get is that inverse function. Okay?
Yeah.
Let's do this one. Don't really need to substitute y for f of x. I could do the same thing by using f of x and just switching those variables. But I think it's a little easier when you use x and y. So what's the next line?
X equals 4y cubed minus 2.
Now solve that for y.
So check or add 2 to both sides. So x plus 2 equals 4 cubed. Then divide both sides by 4. And then take the cube root of both sides.
So you can either write it like this, but the preferred way, I think, is when I take the cube root of both sides, I'm doing this.
All right.
If I'm taking the fourth root of both sides, I'm raising each to the fourth power. In other words, when you raise something to the third power, 1/3 power, that's the same as taking the cube root of it. If I raise it to the 1/2 power, that's the same thing as taking the square root of it. Well, the right side is left with just y. In other words, I'm double exponentiating here, so I'm going to multiply the exponents. 3 times 1/3 is 1. And the left side is that. Or if you prefer, the reason I don't particularly like the bottom notation is that it's easy to make a mistake or misinterpret that for the square root, or think this 3 is acting on a variable if I had something in front of it. In other words, there's lots of ways to misread this. Whereas if I make it to the 1/3 exponent, there's no way to misread that. Okay. Do you have another one that's not on this page that you can read? Or do you have any other problems? Let's see, am I seeing everything?
I did actually pretty well. Yeah, that's all.
That's all you have?
I did pretty well in the grade, except those 4 problems.
Okay. I'll give you one that'll make you think for a moment. It's the inverse of that. First step?
It's the x equals y squared minus y minus 2.
Can you solve that for y? No. Very difficult. In fact, for the math you've been taught at this point, you don't know how to solve that for y. There is a way, but it's not easy. You have to treat x like it's a constant. In other words, you see why this is tough to solve for y?
Yeah.
Can't do it. I don't know how to break it apart to isolate a y out. So when all of the problems they give you that ask for inverse, they're not going to look like this. They're not going to be quadratics, because quadratics are really hard to solve for the inverse. Notice the two problems they gave you. One was linear. That's linear. And that's cubic, because I could solve for y. Once I had y cubed, there was no problem solving for y. But when it's a quadratic and you have both a y squared and a y, it's much harder to solve for. It's doable, and it's a real interesting solution. The technique is super interesting, but I'm not going to confuse you unless you ever get a problem like that. Make sure if you ever get a problem like that that we talk about it, because the solution is not obvious at all. It's quite difficult to even understand. You got anything else you want to cover tonight?
No.
Take a quick look just before I let you go.
Actually, one more.
Okay. Can you read it?
Yeah. So the cube root of 2 minus 25.
Is this finding the inverse?
No, this is just solve the equation and check your solution.
Okay. The cube root of what?
2 minus 25x squared equals 5x. Or, not the cube root, the fourth root.
This is 4?
Yeah.
And this is x squared?
5x.
5x?
Yeah.
Okay.
Yeah.
Well, I got to get rid of my radical sign, right?
Yeah.
Okay, how do I do that? In other words, I can write this. It's a little easier to see if I write this as to the 1/4 power. Now, how do I proceed at this point?
Do you just multiply both sides by 4?
No,
Or,
I would exponentiate both sides to the 4th power.
yeah.
In other words, I've got to take this whole left side to the 4th power, and I got to take the whole right side to the 4th power. Now I can multiply that 4 by 1/4, and I'm left with that. So I have 2 minus 25x squared equals 625x to the 4th. Now, if I rearrange this, you with me?
Yeah.
That's what I get. How can you solve that?
Can you solve by factoring?
This is a quadratic in disguise. It looks like a quartic, but a quadratic, the only thing a quadratic needs is for this term to be the square of this term. And in fact, let me show you the easiest way to do these. It's to use a technique called substitution. I am going to let u equal 25x squared. Okay? Well, 625 was 5 to the 4th, which means it's 25 squared. So this becomes u squared. That is u squared, right? U squared is equal to 625x to the 4th. So that's u squared plus u minus 2 equals 0. That is a quadratic that I can quite easily solve. Go ahead and solve it. Factor it. Excuse me. Factor u squared plus u minus 2 equals 0. Factor that.
So it just be u and u, and then
What are the signs?
negative. Both negative.
No. If that sign is negative, the signs have to be opposite one another.
Oh.
So it's plus minus. So it's plus minus. Now what are factors of 2? 2 and 1. I put the larger one with the plus sign because that's the sign of the middle term. So the 2 goes there, the 1 goes there, and that results in a middle term of plus u. So I've done it correctly. So solving this, I get u equals minus 2 or u equals 1. Well, what was u? U was 25x squared, right?
Yeah.
So I've got 25x squared equals minus 2, or 25x squared equals 1. Well, 25x squared can't be equal to minus 2. That's an extraneous solution. But this is not. If x squared is equal to 1 over 25, then x is 1 over 5. And there's my only solution to that problem. Okay? Now, you didn't have to actually use this u substitution technique. I could have started from this and broken it down into, in other words, I could have factored this. Well, that would have been 25x squared plus 2 times 25x squared minus 1. Notice that that gives me that quartic. In other words, I still factored it like I would normally factor a quadratic. I just did it without going through the u substitution. In other words, I broke that down into 25x squared times 25x squared. And then the rest of it just kind of unfolded. And so I can still go through now, set this equal to 0 and that equal to 0 and solve it. So when you have a quartic that is actually a quadratic, you can solve it. You don't have any other way of solving quartics. In other words, without solving this as a quadratic, you would have no way of solving it, nor would your teacher. She wouldn't know how to do it. Factoring quartics and cubics is a whole nother ballgame. Unless the quartic is actually a quadratic in disguise. And that's what this is. It's just difficult to see. But just know this, that if they're giving you something that has an x to the 4th in it, it's going to be a quadratic in disguise. Actually, I didn't solve this quite right. When I got down to here, x squared equals 1/25. X is equal to plus or minus 1/5. I did the same thing that I'm always complaining all my students always do, which is to leave off the plus or minus. And plus or minus 1/5 is, both of them are solutions to this problem. You go in and substitute plus 1/5 or minus 1/5, this will be true. All right. Mitch, enjoy your golf. You have to leave. You start tonight?
I've been doing this since October.
Oh my goodness. Wow. How's your golf game? It's getting better?
Yeah.
Good.
I've averaged an 8, 9 now.
That's good. That's really good.
Yeah.
All right. Well, enjoy it. Hit them good. I'll talk to you next Monday.
You too.
Bye-bye.